So today we're going to do some special case factoring and then also use this to solve some polynomial equations. And so in the front we're just going to do sum and difference of cubes, just some factoring, and then on the back we'll actually solve some equations. So you'll notice everything I'm going to do on the front side of this has no equal sign. It's just factoring, like we would factor a quadratic into two binomials. Now, what we're going to do here, sum and difference of cubes formulas will be given to you guys on any tests or final exams. So I'm going to write down before I start that, what am I talking about when I'm talking about a cube? So hopefully you guys know perfect squares like 1, 4, 9, 16, 25. So perfect cubes. And I'm just going to kind of write these down the side. So perfect cube, so 1 to the third power is equal to 1. So what that means, the cube root of 1 is equal to 1. So I'm just going to kind of write the list here. So 2 to the third, so 2 times 2 times 2, this is 8. So what that means, the cube root of 8 is equal to 2. And I'm just going to write several of these. 3 to the third power is 27, means cube root of 27 is equal to 3. So instead of taking a square root, we're going to think about cubes today. 4 to the third is 64, 5 to the third is 125, 6 to the third is 216. Oh man, I was going to try and stay on the page here. This is 343. I'm going to have to scooch this up a little bit. Sorry, I'll go back to the definition. I'm going to go up to 10. So 8, 9, and 10. Let me see if we can fit these on the screen here. This is 512. This is 729. And this is 1,000. So I would keep this list handy. And I know I wrote down kind of the cube roots, how they work for those first three. And I could keep writing those down. But as long as you can kind of keep with the pattern. So like the cube root of 64 is 4, the cube root of 125 is 5, and on down. I would keep this list of numbers in front of you while you're trying to work on this assignment today for sure if you're not familiar with them. If we were in the classroom, we'd have this written up on the board so you could reference it. But these are all perfect cubes, number to the third power. Okay, so we're going to do two things today, the difference of cubes and the sum of cubes. So I'm going to slide this back. Okay, difference of cubes works like this. And I'm going to use A and B because if you guys get into a textbook or something like that, that's what they're going to use. But this is not referencing the quadratic formula or quadratics at all. So A cubed minus B cubed. So if you've got these numbers here, that I've got on the side, if you can find this can be factored into, whoops, my apologies, a minus b times a squared plus ab plus b squared. I know this is weird, so I'm going to show you how this is going to work. Okay, here's what I have. X to the third is written exactly like that, so I'm just going to rewrite it with like a little parenthesis around it. And what you want to notice is you're looking for numbers on this list. So if you see 8 is the second number down there. So I'm going to rewrite 8 really quickly as 2 to the third power. Okay, so here's what this means. In my formula, everywhere I see an A, I'm going to replace it with an X. And everywhere I see a B, I'm just going to replace it with the number 2. So this is the factored form. So this would be x minus 2. A squared would be x squared. Now this is a little weird. A times B would be 2 times x. And then B squared would be 2 squared. So 2 squared is going to be 4. Okay, now this is just the factored form. I'm not solving an equation. This is going to help us when we do some problems on the back. Now, for this problem and this problem only, let me show you if you multiply this back out, it will give you what we started out with for this problem only. So if I do a FOIL here, remember this is like FOIL on steroids, like a triple distributive property. If you want to draw yourself a box, you could draw yourself a box for this. It's totally up to you. But let me go through, I'm going to multiply this out. So x times x squared, whoops, would give you x to the third. X times 2x gives you 2x squared. X times 4 gives you 4x. Negative 2 times everything. I get minus 2x squared. Negative 2 times 2, negative 4x, and negative 2 times 4 is negative 8. Now, if you go back through here and look, these two terms cancel each other out, the 2 and the negative 2, the 4 and the negative 4. So all these terms are wiped out, and what you're left with is what we started out with, which is just the x cubed and the minus 8. So this is just the factored form. And when we have the factored form, that's going to make it easier for us to solve equations, which we're going to do on the back. Okay, so the trickiest part of these questions is obviously just identifying the cube that you're working with, which if you're not familiar with these numbers, you want to be. So like 27 is on the list, 64 is on the list. So what I want to do is get myself, let me slide this over so you guys can see my roots here. So like here, cube root of 64 is 4. So I'm going to rewrite this. This is 3x to the third power. So if I took both of those to the third power, 3 to the third is 27, x to the third is x to the third. So I'm just rewriting this real quick. 64 is the same thing as 4 to the third power. So I'm going to try to rewrite this. So then my a is 3x and my b is 4. Then I'm just subbing it into the formula that we have at the top. So let me slide this back down a little bit so you guys can see that formula on the screen. So a minus b is 3x minus 4. Now this is always the trickiest part for people. So right here is a squared, so it's going to be 3x squared. You have to square the 3 and you have to square the x. Now if you guys do this real quick with me, 3x times 9x squared gives you the 27x cubed. So that's probably the hardest thing. If there's a number in front here, you got to square the number and the variable both to get that term. Now a times b, 3x times 4 is going to be 12x. And then the last term is b squared. If b is 4, we're going to square 4, and that's going to give us the 16. Okay, now I have one more example. This one, if you guys notice, those two numbers are not on the list that I've got over there. So if that happens and it's set up in this format, what you want to see is like, okay, is there a greatest common factor? So both of these numbers are divisible by 4. So we're writing the factored form. So I'm going to take a 4 out in front. And if you take 108 and divide that by 4, you're actually going to get 27. Okay, now the factored form here would still need a 4 in the front, but what you got going on, you have x cubed minus 3 cubed. So in the formula we got for the difference of cubes, sorry, I didn't leave myself enough space, is going to be x and b is going to be 3. So this is going to be x minus 3, x squared, a times b is x times 3, so it would just be 3x. And then b squared is going to be 3 squared, so this would be 9. So this would be the answer I'm looking for. Okay, now sum of cubes works extremely similarly. The formula just looks a tiny bit different. So this is a cubed plus b cubed. Here's the difference. This is a plus b. And then a squared, the first term is minus ab and then plus b squared. So basically these switch from the difference. So the difference of cubes, you have a minus plus plus, and for the sum of cubes you have a plus minus plus. This works the same way where it's going to cancel out all those middle terms. So we're just identifying a and b again here. 125, if you're looking at that list, is 5 to the third power. So we're just going to sub these in. So a, I'm going to replace with x, b, I'm going to replace with 5. A squared would be x squared. A times b would be 5x, but it's going to look like a minus 5x the way that's laid out. and then b squared is 5 squared, which is 25. That's your factored form. That's all you got to do. If you guys back up, and I know you can't see it on the screen here, these numbers are both perfect cubes. So 64 is 4 to the third, and 729 is 9 to the third. So my a is 4x and my b is 9. Now this one's a little trickier, especially if you have a number here. So I have 4x plus 9. Okay, now a squared is 4x squared, and so I have to square the 4 and I have to square the x, so that term's going to give me 16. Now if you check this real quick, 4x times 16x squared gives you back the 64x cubed, so don't forget to square that 4. That's the main thing people forget. A times b is going to be 4x times 9, so 4 times 9 is going to be 36. And then when you're working with the sum of cubes, the second term's always got a subtraction sign. And then the last term is b to the third, I'm sorry, b squared. So 9 squared is 81. This is your factored form. And then the last one here, this actually is kind of interesting. So 2's not on the list of perfect cubes. So the other thing that's interesting here, both of these terms have an x. So I'm going to take a greatest common factor out in front. So if I do that, I've got to keep the 2x. This term would become x cubed. Now this always trips people up, but 2x divided by 2x, that actually just turns into 1. And 1 is on your list of perfect cubes. So here we have x cubed plus 1 cubed. Now when we're writing the factored form, that 2x has to stay out in front. Okay, so my a is going to be replaced with an x, and my b is going to be replaced with the 1. So I have x plus 1, x squared, minus just 1 times x would just be minus x, and then 1 squared, don't put 2, 1 times 1 is 1. So this would be your completely factored form. The reason we're doing this is because we're actually going to use this to solve these equations. You'll notice they're all set equal to 0. I'm not going to lie to you. These have imaginary answers, and so they're not always the nicest values when you go through here, and you do always have to use the quadratic formula to solve these problems. So I'm going to go ahead and do what we were doing on the front. I'm going to put these in factored form, and then we're going to use the factored form. So here's my first problem. This is x cubed plus 2 cubed. We did this on the front with the difference, so let me just factor this real quick. This is a sum though, so this is going to be x plus 2, x squared plus 2x plus 4. So that's what we're doing on the front. The difference is I'm going to use the factored form to solve the equation. So if two things are multiplied together to give you 0, either this has to be 0, so negative 2, if we would plug that in, and then always, there's no exception on these problems, you have to use the quadratic formula to get the zeros of the other. Like, you won't be able to factor that any further. The easiest way to do it is use the quadratic formula. So if you don't remember that, just focusing on this quadratic, pretending this is set equal to 0, and that's the only problem I have. If you guys remember, negative b plus or minus square root b squared, whoops, minus 4ac all over 2a. So when you get the quadratic, the linear part, this is just going to be negative 2. Just set that equal to 0. If I set that equal to 0, I got to use the quadratic formula for all these problems. They won't be factorable. So if I'm just focusing on this, a would be 1, b would be 2, and c would be 4. So opposite of b, plus or minus the square root b squared minus 4ac all over 2a. Now, I promise you, every single time you do a sum or difference of cubes, you're going to get a negative number under the square root. So if I'm doing that problem, I'm just going to grab a calculator to show you guys. So under the square root, 2 squared minus 4 times 1 times 4 is going to be negative 12 all over 2. Okay, now I promise you, and it says this in the directions up here, this number, if you've done this problem correctly for any of these sum or difference of cubes, will always be divisible by a perfect square and 3. So if you divide this, I'm just going to break down that radical. 12 is 4 times 3, negative 12 is going to be negative 4 times 3. Now, this one can be simplified a little bit more. The square root of negative 4 is 2i. So square root of 4 is 2, negative 4, you just put an I with it. Okay, now, this, don't touch this, but all these numbers here, including the imaginary one, they're all divisible by 2. So I'm literally just reducing this fraction. This is negative 1 plus or minus I radical 3. Okay, so back up to the equation. We're going to talk about this more later, but the number of answers that you should have to any polynomial equation is going to match the highest power of x. So for this question, that's 3. So I should have 3 answers. Negative 2 is one of the answers. And then down here, this plus or minus gives me 2 different answers. Negative 1 plus I radical 3 and negative 1 minus I radical 3. If you did actually plug these numbers in for x, when you simplified it, it would equal 0. So you could plug in negative 2, that would make it 0, and then either one of these imaginary numbers, if you want to plug that in to check, it will make it equal to 0. Okay, let me do one that's a difference right to the side. So this one, x to the 4th, I should have 4 answers. So first thing I'm going to notice is neither of those two numbers are perfect squares, but they are, or perfect cubes, sorry, but they are both even, and both of these terms have an x. So I'm going to take a 2x out in front. Left over would be x cubed minus 27. Okay. So here, the x cubed minus 27, I have x cubed minus 3 cubed. So this is a difference of cubes. So if you need to look at that formula, go ahead and look on the front. This will factor into x minus 3, x squared plus 3x plus 9. Your a would be x, your b would be 3. So I have a minus b, a squared plus a times b would be 3 times x. And then 3 squared is 9. Okay, now we should have 4 answers here. Right in front, 2 times x, just 0 is one of my answers. So if I plugged in 0, that would wipe out everything, solve the equation. Answer here would be 3, so I should get 2 more. And just like I was telling you guys, you always have imaginary answers with these sum and difference of cubes. This is a difference of cubes, but you got to use the quadratic formula on that. Oh my gosh, guys, stop here for a second. I'm just realizing that I didn't do this one right. Sorry, there's one little change I'm going to make, and this is not going to change my answer except for a negative sign. Forgive me, I mixed these up. This should be a minus, so this will be a plus. It's not going to change anything else because when you square negative 2, that still becomes positive 4. So I'm just going to go down the line here. These should all be pluses. The only thing that's going to change, this would be positive 1. I apologize about that. I didn't notice. This is the sum of cubes, so this should be plus, minus, plus. Here, when you do difference, it's minus, plus, plus. So this one is factored correctly, so forgive me for that. Everything else is the same. It just that 2 out in front should have been positive instead of negative, because this should have been negative 2. Opposite of that would be positive. Okay, quadratic formula. A is 1, B is 3, C is 9. So opposite of B. Negative 3 plus or minus square root 3 squared, 4 times 1 times 9, all over 2 times 1. So negative 3 plus or minus. Okay, I'm going to grab my calculator and figure out that number. So 3 squared minus 4 times 1 times 9, negative 27. I always promise you, if you've done this correctly and you're using a sum or difference of cubes, this number will always break down to be divisible by 3 in a perfect square. So 27 divided by 3 is 9. Okay, square root of negative 9 is 3i. So we have negative 3 plus or minus 3i radical 3 the whole thing over 2. Now, different from the last problem, don't ever touch the radical, but these numbers are not divisible by 2, so I cannot break that down. So that's my other set of answers. So let me pull this so you can see. Original problem, x to the 4th, I should have 4 answers. Taking out the greatest common factor leads me to have 0. So I have 1 answer here. This part of the factored form would be positive 3 as an answer. So 1, 2, and then with the quadratic formula, because of the plus and minus, you get 2 answers. And then I just have one more down here. This one is one we factored something similar on the front. This is 4x cubed plus 7 cubed. Okay, so let's go ahead. We're going to solve this equation. Your a is going to be 4, your b is going to be 7. This is the tricky case where it's a little bit harder to factor this. So this is a sum. So I'm going to have 4x plus 7. Now this term is 4x squared. So we're going to get 16x squared. This should be a minus sign if I'd done that properly on that other one. Okay, a times b. So 4x times 7. This term would be 28x. And then the last term is b squared, which is 7 squared, so this is going to end with a 49. This is the factored form, but because I have an equation, I actually have to solve this. Okay, now for this one, remember, it's whatever sets it equal to 0. So I'm going to take 4x plus 7, set it equal to 0. So I'd subtract 7, divide by 4. So negative 7/4. That's one of my answers. Highest power of x is 3, so I should have 3 answers total. Now, always, always, always on these, this is going to be imaginary. I'm going to use the quadratic formula. I wanted to use this as a practice question because these numbers are a little bit bigger. So a is 16, b is negative 28, c is 49. So opposite of b is going to be 28 plus or minus negative 28 squared, 4 times 16 times 49, 2 times 16. So this is going to be a little bit bigger number to simplify. Excuse me. Okay, let me grab. Okay, now make sure that negative 28 goes in parentheses and the squared goes on the outside because it should become positive when you square that. 4 times 16 times 49. We're going to end up with 28 plus or minus the square root 2352. Okay, now this is where you got to remember, just sum and difference of cubes. I always swear to you, this number will be divisible by 3 in a perfect square. So I'm just going to go ahead and take that, divide that by 3 on my calculator. Now, I don't even know that off the top of my head, so I'm going to have to figure it out as we go here. This is 28 plus or minus. Just trust, if you have done this properly, that that 784 is going to be a perfect square. Okay, so 784, whoops. I'm going to take the square root of 784. All right, we got 28. So I get 28, square root of this will be 28i because it's negative. All right, now, if you guys look at this, I move my calculator out of the way. Now, don't touch that radical 3. 28 and 32, those two numbers are divisible by 4. So for my answer here, let me break this down. 28 divided by 4 is 7. For both of those on the top, 38 divided by 4 is 8. My other two answers, I did not mean to cross that out, are going to be 7 plus or minus 7i radical 3. Whenever you do the sum and difference of cubes, the quadratic part of it will always have a radical 3 when you do the quadratic formula.